So welcome back to Master Academy of Mathematics. This is the last topic of your particular integral. When the right side looking like x power k into v, where v stands for either sin ax or cos ax. So I just give you the brief procedure. So represent your given higher order ordinary differential equation in the symbolic form, that is f of d of y equal to q. Find out the complementary function by the auxiliary equation f of m equal to 0. Find out the particular integral yp equal to 1 divided by f of d of q, that is equal to 1 divided by f of d, and q is nothing but your x power k into v. So just I am substituting 1 divided by f of d x power k. V stands for either cos ax or sin ax. So depending on that cos or sin, now I am taking Rp stands for real part. Ip is nothing but imaginary part. So if it is cos, you write down real part, and sin, you are using the imaginary part. So depending on the V, either you can take real part or imaginary part of 1 divided by f of d x power k into, instead of writing those two, I am just writing e power iax. Then you are writing the same part and you are taking only e to the power of iax to the left hand side, so that the d is replaced by d plus ia, and x to the power of k you are keeping as it is. Now you apply the previous method for q equal to x to the power of k, and just you do the simplification. Finally you are taking only the necessary part. Necessary means if it is cos, you take only the real part, and for sin you are take only the imaginary part, just making the simplification to get your finally yp value. Then find out the complete solution y equal to yc plus yp. Now let us have a problem. D square minus 4d plus 4 of y equal to x square sin x. Look at your right side. It is looking like x to the power of k into v, where v stands for sin ax. A is nothing but there 1. So directly you calculate your auxiliary equation, and m values, 2 values are available. So as per your given problem, m values only 2, 2. Roots are real and repeated. So you are writing yc equal to c1 plus c2x into e to the power of 2x. Is it not? Then you are taking yp, the particular integral, it is 1 divided by f of d of q. It is 1 divided by your f of d means d square minus 4d plus 4, and the q stands for x square into sin x. Now this is equal to, so sin means, is it related to imaginary or a real part? Naturally sin stands for imaginary. So for that I am just writing here imaginary part of 1 divided by d square minus 4d plus 4 as per the procedure. X square you keep as it is. In the place of sin x, you are writing e to the power of I. What is the a value? 1 into x. Okay. Now this is equal to imaginary part of 1 divided by d square minus 4d plus 4 x square into e power I1x is nothing but only ix. Now this is imaginary part of, I am taking only e to the power of to the left side, e power ix, 1 divided by, d is replaced by naturally d plus a, where a is nothing but x coefficient only we should write. So here x coefficient is nothing but I. So d plus I whole square minus 4 into d plus I plus 4, and just the remaining term x square as it is. It is equal to imaginary part of e power ix 1 divided by, write down here directly d square, okay, and plus 2id, so plus 2id, and plus I square means minus 1, so minus 1, it is minus 4d, then the next is minus 4i plus 4, it is of x square. So just to do the simplification, imaginary part of e power ix 1 divided by d square as it is 2id is there and there it is minus 4i. Better you write same as it is, plus 2id, and I think there is no cancellations, so directly minus 1 and plus 4 is there, so it becomes plus 3. So minus 4i, it is plus 3. This is of x square. Okay. Now this is equal to imaginary part of e power ix as it is. So how to calculate that x to the power of k right side value? 1 divided by, you are taking the constant term common, so 3 common, so that it is 1 plus d square plus 2id minus 4i divided by 3. This is of x square. When you are calculating this one, better you just make the simplification. 3 into 1, it becomes 3. 3 into this entire value. On cancellation of 3, again you are getting the same value. So this is about your d square plus 2id, and this is minus 4d, that minus 4i plus 3. So 3 I am taking common, and that I am taking to the numerator. It is equal to imaginary part of, so e power ix as it is, that 1 by 3 is there, just I am writing 1 by 3. If I take to the numerator, it is 1 plus d square plus 2id minus 4d, next minus 4i divided by 3. This is to the power of minus 1, and here is x square as it is. So just I am writing imaginary part of e power ix into 1 by 3. So I don't want to take much more simplification. It is 1 plus x whole power minus 1. Just I am writing 1 minus d square plus 2id minus 4d minus 4i divided by 3. The next becomes that value whole square. So better you just make the simplification. This is of x square. So now it is imaginary part of e power ix into 1 by 3. So I am just making the multiplication. It becomes x square minus 1 by 3 as it is. What about the d square of x square value? Second derivative is 2, and plus 2id, d stands for 2x, so it becomes 4ix minus 4d, that the first derivative 2x minus 8x, and minus 4x square I. This is for the first one. Similarly, if I take square of the next term, somewhat you will get the next term also. Just you do the simplification. And now I am substituting here imaginary part of, what is actually e power ix? The formula is, it is cos x plus I sin x. Suppose e power I 2x is there, then cos 2x plus I sin 2x. It is 1 by 3. And multiplication here, it is x square minus 2 by 3 and minus 4 by 3 into ix plus 8 by 3 into x plus 4 by 3 into x square into I. So now this is equal to imaginary part of, so here the problem is nothing but we need to get only the imaginary part. Imaginary part means you write down only the I terms. So what are the different I terms you are getting? Can you guess only the items? Write down only items. If it is a real part, you take only without having I part. So I am writing only the imaginary part combinations. So cos is multiplied by, for which value you are getting imaginary? So that 1 by 3 it is you are keeping as it is. This is multiplied by, for imaginary, it is cos x into minus 4 by 3. That you will get into x. And one more term is plus 4 by 3. It is cos x into x square. Only I terms. Similarly, this value is multiplied by plus x square into sin x. You will get I term. And minus 2 by 3 into sin x. One more I term. When this is multiplied by this, I square becomes minus 1. It is not having I term. Similarly, this value multiplied by plus 8 by 3 into x sin x. And if it is multiplied to the last one, you will not get I term. So this is nothing but only you are taking imaginary part of corresponding simplifications. This gives you complete yp. So after getting that, just you write down y equal to yc plus yp. Once again, I remind you, when you are taking imaginary part, write down only the I combinations. If it is real part without I combinations, you need to write down the values. Now let us have an exercise problem. D square minus 1 of y equal to x square cos x. Are you taking real part or imaginary part? Only real part. So based on that, you directly find out the same simplification. One more is d square minus 4d plus 4 of y equal to 8x square sin 2x. Instead of giving only sin x, here it is sin 2x is given. So that you are taking imaginary part. How to write down that imaginary part? E to the power of I, a value is 2, I 2x. So when you take to the left side, d is replaced by d plus 2i. And just you do the simplification and find out the answer. Better those who are doing this type of problem, and you give the complete solution of this second problem in the comment section, so that I give you whether it is correct or wrong. So with this, the complete methods on particular integral is closed. In the next video session, we directly enter into Cauchy-Euler formula. Have a good day.